In the previous workbooks, you have learned how to calculate masses of reactants in products using reaction stoichiometry. You've also learned how to calculate quantities using gas laws and ideal gas equation. In this video, you will learn how to calculate volumes of gases consumed or produced in a chemical reaction using reaction stoichiometry and the gas laws. There are two gas laws that we'll apply in this workbook. You're familiar with the first one, that is Avogadro law, which says that equal volumes of all gases, when measured at the same temperature and pressure, contain equal number of particles. From this law, we have derived mathematical expressions for molar volume and ideal gas equation. And you can calculate the volumes of gases at STP and RTP conditions, and you can also calculate the volume using ideal gas equation. Another law is the law of combining volume. It states that when measured at constant temperature and pressure, the volume of gases taking part in a chemical reaction shows simple whole number ratio to one another. Let us first apply law of combining volume to calculate volumes of gaseous reactants or products. For example, if you have a reaction like nitrogen reacting with hydrogen to form ammonia, you'll notice that all the reactants and products are gases, so you can apply the law of combining volume to this. And the molar ratio would be 1 mole of nitrogen reacting with 3 moles of hydrogen to give 2 moles of ammonia. Now, according to the law of combining volume, the volume ratio is the same as the molar ratio. So, for example, if you have 100 milliliters of nitrogen, it will react with 300 milliliters of hydrogen to give 200 milliliters of ammonia. So, for example, if you have 4.5 liters of nitrogen, then how much of hydrogen would react with it? So you can multiply 300 with 4.5 and divide it by 100, and you would get 13.5 liters. So you can calculate the amount of hydrogen reacting with nitrogen. Similarly, if you have 600 milliliters of hydrogen reacting with excess of nitrogen, you can calculate the amount of ammonia formed. And in this case, it would be 400 milliliters. You can also apply Avogadro law to calculate volumes in chemical reaction. So, for example, you have sodium azide, and it decomposes to form sodium in the solid state and nitrogen in the gaseous state. And you have to calculate the volume of nitrogen gas formed when 10 grams of sodium azide decomposes. So the mass of sodium azide is given, and you have to calculate volume of nitrogen gas. So the first thing you would do is calculate the amount in moles of sodium azide, and you would get 0.154 moles. From this, you will calculate the amount of nitrogen gas formed. So 2 moles of sodium azide forms 3 moles of nitrogen, so 0.154 moles would give 3 times 0.154 divided by 2, which is 0.231 moles. Now that you have the amount in moles, all you have to do is use the ideal gas equation to calculate the volume of nitrogen. The volume of nitrogen would be the amount in moles of nitrogen gas, which you've just calculated, and times it with 8.314, that is R, and 300 would be the temperature in Kelvin, and pressure is 110, and you get the volume 5.24 liters. And if you have to report it in milliliters, you simply multiply it by 1,000. So in the workbook, there are 10 questions where you get to apply law of combining volume and Avogadro's law to calculate volumes of reactants and products. So good luck and enjoy.